Hello friends, this is Atul Shingarwadi here. I welcome you all in this video lecture series over data mining and data warehousing. Now here in this video we are going to discuss one of the very important method called as what we can say a priori method. Okay, that is used for mining of frequent patterns. Now let us discuss what this particular a priori method is. So basically, in my last video, I have specified that any subset of a frequent item set must be frequent. Now, this is what a very important, what we can say, property, okay, of frequent item set mining, and that is known as what we can say a downward closure property of frequent pattern. Downward closure property of frequent pattern. What that property says? Any subset of a frequent item set must be frequent. Now as an example here we are having three items inside the what we can say item set, that is beer, diaper and nuts. Now if we say this particular beer, diaper and nuts appears many times or frequently inside a transaction database, then the subset of that is considered as beer and diaper, that is also considered to be a frequent one. Are you getting this? Okay. What is the downward closure property of this particular frequent patterns? The downward closure property of frequent patterns says that any subset of a frequent item set must be frequent. Any subset of frequent item set must be frequent. Now for this we are having an example like beer, diaper and nuts. These are the three items, okay, in a particular transaction data set. And suppose if those three items are frequent, okay, then the subset of that is what we can say a beer and diaper, that is also what we can say a frequent one. That is, every transaction having what we can say beer, diaper, nuts also contains beer and diaper. Now this is what a downward closure property of frequent item set or frequent patterns. Now by taking help of this particular property, okay, we are going to find out what we can say the frequent patterns, okay. And as I have already mentioned in my last video, there are basically three methods, okay, which are considered as scalable mining methods, okay, that are used to find out this particular frequent items inside the data sets, okay. And those methods are nothing but what we can say the a priori method, as I have already mentioned here. Then we can have what we can say a frequent pattern growth, which is also called as in short FP growth, and then we can have a vertical data format approach. Now among these three, a priori algorithm that we have to discuss here in this particular video. Okay, this algorithm is basically proposed by Agrawal and Srikant in 1994 in the conference. Okay, in the conference of this particular what we can say conference over data mining. Okay, now what this particular a priori algorithm is? So this a priori algorithm is nothing but it is a candidate generation and test approach algorithm. It is a candidate generation and test approach algorithm. Okay. So here we are going to generate what we can say the candidates. Now what that particular candidates are? So candidates are again nothing but these are the item set. Candidates are nothing but these are the item sets. Okay. Now while what we can say doing this particular or while applying this particular a priori algorithm, basically here we are having two steps. The step number one is called as what we can say self-joining. Here the items from that particular item set that gets joined with each other, okay, to form what we can say the different patterns. And in another second step, we are going to prune those particular items, okay. Now what that particular pruning is, so pruning is nothing but it is the process of what we can say removing those particular data items that do not occur frequently, okay. So by making use of this particular pruning technique here, okay, we are going to generate the different candidates, we are going to test it, and this particular methodology is what we can say continued till we find one such particular item set which is null, which is infrequent, okay. Now what this a priori pruning principle says, if there is any item set which is infrequent, its superset should not be generated or tested. Okay, keep in mind, this is what a very important principle given by a priori, okay, regarding this what we can say pruning. So a priori pruning principle says that if there is any item set which is infrequent, okay, if there is any item set which is infrequent means that do not appear frequently, then its superset should not be generated or tested. Of course, it is of no use. If suppose the item set is infrequent, then its superset should not be generated or tested because it is of no use. Now, what is the methodology for a priori pruning principle? The methodology says that initially scan database. Now, what the method is for a priori method? Initially scan database wants to get frequent one item set. Now, see, initially we have to scan at the start. We have to scan this particular database to get frequent one item set. Now, what is that frequent one item set? Now, here always we have to go on in what we can say increasing that particular item set. So, frequent one item set is nothing but an item set having every individual item tested for what we can say frequency. Every individual item of that particular item set is separately tested for what we can say frequent appearance. Okay, that is known as what a frequent one item set. Okay, so this is what of course we are going to discuss this with the help of certain example. Okay, where I will have certain what we can say the data set and then how that frequent one item set can be obtained. So that we are definitely going to discuss in the next slide only. Okay. So initially we have to scan this database once to get frequent one item set. Now once this process is done, then we have to generate a length k plus 1 candidate item set. So from that particular frequent one item set, we have to generate a candidate item set having length k plus 1. So where k is nothing but what we can say the total number of items in the item set. Okay, now from length k frequent item set we have to generate this means we are having one frequent item set of length k and we are going to generate a candidate item set of length k plus 1. Once that is done, in third step we have to compare that particular candidate item set which is generated, okay, along with what? The database, okay. And then while comparing that, we are going to what we can say remove those particular items from that particular candidate item sets which do not support or which do not what we can say satisfy the minimum support criteria. Now keep in mind, whenever any type of frequent item sets are generated or whenever any types of association rules are to be formed, okay, because we know that for forming association rules we have to first generate frequent item sets, okay, and from that particular frequent item sets we are going to specify certain what we can say associations, okay. So whenever those particular candidates are generated, from those particular candidates we are going to prune or remove those particular associations or those particular items that do not satisfy minimum support criteria. What I was just talking about, whenever association rule mining is there or whenever certain frequent item sets are to be formed, okay, at that time the minimum support and minimum confidence, these are the two very important measures that are to be taken into consideration. Okay, so of course we are going to discuss it in the next slide again. Now once this particular candidate generation is done and after it is tested with that particular what we can say database at the start, then the next very important step is that terminate when no frequent or candidate set can be generated. Now of course whatever these two steps are there, step number 2 and step number 3, that is what generation of k plus 1 length candidate item set from k frequent item sets, okay, and then the third one is what testing that particular candidates against database. So this particular process is repeated, okay, this process is repeated to form the new candidates, okay, to form the new candidates, and this particular process is to be terminated of course when no frequent or candidate set can be generated, because we are continuously generating those particular candidates here. So whenever that particular what we can say candidate generation is stopped or whenever a frequent what we can say frequent item set will not be found, in that particular case we have to what we can say stop this particular or terminate this particular process, and that will give what we can say in the last step of course that will specify what the frequent item sets are inside that particular database. So this is what the methodology. We are going to discuss the algorithm over that particular one of course, but before that let us consider what we can say. Let us consider this particular example here, the a priori algorithm an example. Okay. Now suppose consider this is what we can say a database given. Okay, this is what a database TDB, which stands for what we can say the transaction database. Here, 4 transactions are recorded, of course. Okay, 4 transactions are recorded, and those 4 transactions, of course, are nothing but what we can say that are given as what we can say transaction number 10, 20, 30, and 40. If we observe here, there are what we can say transaction number 10, 20, 30, and 40. Okay. In transaction number 10, we are having A, C, and D. These 3 items are purchased. In transaction number 20, we are having B, C, and E. These 3 items are purchased in the sequence. In transaction number 30, there are 4 items, and in transaction number 40, we are having 2 items again that are purchased. Now, if this is what the initial situation of this particular transaction database, then we have to apply the a priori algorithm or a priori principle over this particular database to find out what we can say the frequent item sets. Now, to get this, of course, as I have already mentioned, to find out the frequency or to find out the frequent items, we have to specify which item should be considered as frequent, how many times it should appear inside the database so that it can be considered as frequent. Okay, so that can be given by specifying what we can say the minimum support criteria value, and this minimum support criteria value is given as what we can say 2 here. Minimum support value is given as what 2. So to say a particular item frequent, to say a particular item as frequent, it should appear at least 2 or more than 2 times inside the database. This is what the concept behind this, what we can say, support minimum. Okay. So, if we try to generate the candidates from this particular, what we can say, the first candidate from this particular transaction database inside the first scan, where inside the first candidate we always know that it is called as one frequent data set. Okay, as I have already mentioned in my last stage, okay, last step of course. Okay, at first initially we have to scan it to find out one frequent item set. Okay, and for one frequent item set, what I have specified among all those particular transactions, find out the different items. Okay, and here we are having how many items? A, then B is there, then even C is there, then D is there, and then E is there. So we are having 5 items A, B, C, D, and E. So for finding out one frequent data set, we need those particular items to be specified separately. We don't want any combination of those particular items. So, and that's why what we can say A, B, C, D, E, those are written separately. Okay, and now here in this particular stage, okay, here in this particular example, the second column specifies what the support. Now, at first find out the support of each of this particular item separately. Support of each of this particular item separately. So we know that this A inside this particular transaction database appears how many times? So A appears here in transaction number 10. Even the A also appears here in transaction number what we can say 30, and that's why the support count of this particular this particular item A is what we can say 2. Likewise, the support count of B is 3 because B appears 3 times. You can see here 20, 30 and 40. These are the 3 transactions where this particular B appears, and that's why the support count of this B is 3. Whereas the support count of C is 3 also. Okay, so we can have this C appears thrice. Okay, in transaction number 10, in 20 as well as in case of 30. And that's why we can say that this B for this particular C, the support count is what 3. Whereas the support count for this D is only 1 because it appears only what we can say inside the first transaction only. And that's why the support count of this D is 1. Whereas the support count of E, that is of course what we can say 3 because it also appears 3 times, that is in 20, 30 and 40 number transaction. So whatever this what we can say candidate is generated, this is considered as one frequent item set. Clear? Now, From this one frequent item set or from this particular candidate number 1, we have to form level 1 item set. We have to form what? Level 1 item set, which is considered as L1. Okay. And this level 1 item set is formed by pruning principle. Level 1 item set is formed by pruning principle. Pruning principle, yeah, pruning stage. Now what is pruning? That I have already mentioned. Pruning is nothing but it is the process of removing infrequent items from these candidates. Okay. As my support count is 2, if we observe here D is one such item which appears only once inside the data set, it means that according to my support count it is infrequent. So remove it and we will get what with this particular item set where A, B, C and E are there along with this particular support count. And this is considered as what we can say level 1 item set. This is considered as level 1 item set. Okay, now if we observe here, okay, once this particular level 1 item set is found, then again over this particular level 1 item set, we have to apply the what we can say self join principle. Okay, as I have already mentioned, in case of a priori algorithm, we have to apply 2 steps. One is what self joining, and another one is what pruning. So self joining and pruning, this we have to repeat. Okay. So till we get infrequent item sets, of course. Okay. Now once this level 1 item set is found, which is what we can say generated from this particular one frequent item set, or rather level 1 is itself known as what we can say one frequent item set, which is generated from this particular candidate 1. Now we have to generate level 2 or 2 frequent item set. 2 frequent item sets. And how this 2 frequent item set is found? That can be found by applying or by combining 2 items from this particular level 1 item set or 2 items from this one frequent item set. So as we are having A, B, C and E. So if we combine this, okay, with the combination of 2, of course, we will have what we can say the combination like what A and B. Okay, if we observe here, okay, if we observe here A and B, then A and C may be there, then we can have A and E, and that's why here we have mentioned this first 3. Then we can have B that can be combined with what we can say C. Then we can have D that can be combined with what E. So if, we can have here, okay. Then we can have C that can be combined with E, okay. Because with the previous one it cannot be combined because it already what we can say occurs inside this particular data set. So this is what the combination. Now if we consider this particular combination, this whatever candidates are generated, these are considered as what we can say C2. Okay, and from this particular C2, of course, we have to scan second. We have to make second scan to what we can say form level 2 database, and that is known as what we can say 2 frequent database. And for that purpose, we will first specify or we will first calculate what is the support count of each of this particular combination inside the original database. Okay. So if we can consider A and B in combination, how many times this A and B appears here? So A and B that appears in transaction number 30. So that appears only once, okay, and that's why the support count is written as 1. A and C that appears in transaction number 10 and in the case of transaction number 30. So the support count of A and C is 2. Then we can have what we can say A and E. So A and E that together appears inside transaction number 30, and that's why the support count is 1. Then what about B and C? So B and C is appeared in 20 as well as in case of 30, and that's why the support count is 2. Then what about B and E? So B and E that appears what we can say in 30 and 40. That's why the support count is what? Of course, B and E that appears also in 20, and that's why the support count is what? 3. What about C and E? So C and E that appears in transaction number 20 as well as in case of 30. So support count is 2. Now this is what we can say a candidate 2 which is generated, which is also called as C2, which is generated from this particular level 1, okay, which is also called as one frequent data set. Now once this candidate is generated, again by making use of this minimum support criteria which is given as 2, we will compare this particular one with minimum support criteria. So These particular combinations like A and B, which offers only one, and then A and E, which offers only one, these are considered as what? Infrequent combinations. And that's why we will remove these infrequent combinations to form this L2. Okay, this L2, and this L2 is called as two frequent item sets. Two frequent item sets, where we are having the combinations of two items from these data sets, and their support count is given here. Now, after this L2, okay, we have to calculate L3, okay, and while calculating L3, we have to combine three items now. We have to combine three items from this particular given one. Now, if we observe here, we are having A, B, C, and E. Now, actually, there is no D. Yeah? So, for A, B, C, and E, whatever possible number of combinations are, okay, those particular possible number of combinations are written again. As like in case of what we can say C2, the C3 will be formed, the support count of those particular three item combination will be written, and whenever we will apply this minimum support criteria over that, then we will get only item set, that is what BCE, only one item, only one what we can say combination BCE whose support count will be 2, okay, and that will match with what we can say the support count which is already provided, so BCE, okay. Now, as we are having only one what we can say association here, or only one data set having BCE as the transaction together, okay, we cannot go for level 4, where in case of level 4 of course we need the combination of 4 items, and that is not possible here with this particular 3, because we are having only one transaction, and that transaction consists of 3 items, so we cannot form level 4, and that's why the level 4 or the candidate in level 4, that will be matched with what we can say a 5 value. 5 value means what? A null value. Null value. Null means what? There will be no items. It means that again there will be no frequent items found for the next level, found for the next candidates, and that's why what we can say BCE along with the support count 2. This is considered as a output of this particular a priori algorithm for this given example. Okay, for this given example. So we can say that what is the use of a priori algorithm? A priori algorithm is used to find out the frequent item set. So, from this given data set, we are having this particular combination B, C and E as a frequent one because it appears twice inside this particular data set. So, this is what we can say an output of this particular one. Now, let us move further. Now, this is what an algorithm basically, जो हमने अभी example देखा, हमने पहले methodology देखी, अब actually algorithm क्या है? So, the pseudocode of this particular a priori algorithm is like this. We are having what we can say CK, that is nothing but candidate item set of size K. Okay, CK is nothing but candidate item set of size K. Then we are having LK, that is frequent item set of size K. Of course, we have seen that particular one. L1, L2, L3, those are nothing but considered as the level, but those levels are nothing but those are the final outputs in that particular proper stages, which are called as what? Frequent item sets. Okay. Now we know that for L1, which is called as what? Frequent items, we will apply from 1 to k equals to 1 to what we can say not equals to 5. So k equals to 1, Lk not equals to 5, k plus plus. Okay, here we are going to generate the candidates. Once the candidates are generated, that will be tested along with what we can say the original item set. Okay, to find out the minimum support. Okay, then after finding out that minimum support, we have to prune. We have to apply that particular pruning technique. So that will remove those particular infrequent candidates. So this will what we can say happen here for each of the value of k equals to 1 to what we can say 5, where every time we are going to increase the value of this k by 1, and likewise what we can say we will generate those particular candidates here. So this is what an algorithm for what we can say finding out those frequent patterns. Now, what are the important details regarding this particular a priori algorithm? Okay, so the very first one is about how to generate candidates. That of course we have discussed it already inside the example. So as I already mentioned, the candidates are always generated by self-joining and then by pruning. So these are the two steps. Okay, self-joining and pruning. So by making use of these two steps, that is what self-joining LK whatever level is there, according to that we have to self join. Okay, self joining is that we have done for frequent item set 1, frequent item set 2, frequent item set 3, likewise. Okay, whatever number of possible combinations are there, that can be generated. After that we are having pruning step. Once that is done, we have to count what we can say support count of that particular candidates. So important details will give what we can say generation of candidates, किस तरह से candidate generate करते हैं. So by making use of self joining and pruning. Once that is done, we have to count what the supports of those particular candidates. Now, example of candidate generation is given here also. So as like L3, where level 3 is there. So of course we need the combination of 3. That is what ABC, AD, ABD like that. Okay, whatever it may be. Self joining, then pruning, and automatically in case of P4 we will require what 4 items together. So these are what the different stages inside that particular a priori algorithm. Now, how that particular candidates are generated, so that can again be given as like what we can say, suppose we are having items in LK minus 1 are listed in the order, self joining LK minus 1, insert into CK. So here we can have what we can say, the queries, okay, and those queries can be applied to what we can say, form those particular candidates together. According to what we can say a particular level. So if we need frequent 1 item set, frequent 2 item sets, then we have to combine those particular one, and that's why it is written P dot item, that is given as what we can say P dot item 1, P dot item 2, P dot item 3. So why we are going to select this and how many items we have to select? So that depends on what we can say what the level is. Which type of frequent item set we have to generate, whether it is level 1, whether it is frequent 2 item set, whether it is frequent 3 item set. Accordingly, we will write these particular items inside the select clause. Of course, from clause is given, where condition is there, where the items will match with together, or that will specify that particular, satisfy that minimum criteria value. Then once this is done, self joining step, then we have to apply the pruning step, and in case of pruning step, of course, we are going to delete. Okay, now that's why this particular verb is written here or query is written here. We are going to delete what infrequent items, and that's why it is said that if S is not in LK minus 1, then delete C from CK. Matlab, we have to delete those infrequent data sets which do not satisfy the minimum criteria. So likewise, these particular candidates are generated, of course. Okay. Now, how support count of the candidates are given? So, of course, support count, we know that the support count is already given as a minimum support count at the start of this particular process. Okay. So, again, the same thing is given here also. कि जो भी candidates हमारे generate हुए हैं, we have to compare those particular candidates. We have to tally those particular candidates support along with the support count, minimum support count that is given, and that can be done by making use of what we can say the different techniques. Okay, so now this is what we can say counting supports of candidates. So we can apply certain tree approach also. By making use of tree approach also, we can calculate the support count. Okay, or you can compare the support count, but of course that is of not that much of use, because we can directly what we can say by writing certain algorithm or by converting those particular algorithms into programs, we can easily find out those particular what we can say item sets that do not satisfy the support count, that satisfies the support count, or even what is the support count of each of the combination. So that can be done logically, of course, by making use of different techniques. Then what are the different challenges here in frequent pattern mining? Now this is very much important one. The major challenge is what we can say in case of a priori algorithm, we required what we can say multiple scans of transaction database, of course, as I have already mentioned. Okay, so multiple scans required as the number of data items increases inside the transactions, or as the products in the particular shop, those are what we can say increased, and the customers will purchase those particular product in the variety of combinations, then automatically the scans over that particular database will increase. Then huge number of candidate generation will always be there, of course, because according to what we can say the different combinations, either level 1, level 2, level 3, so such types of candidates will be generated. Tedious workload of support counting for candidates, of course. So if there are huge database, or if they basically, of course, data mining process is to be applied over the huge databases. So if there are more number of transactions inside the databases, of course there will be a tedious workload of support counting for candidates. Then these are what the challenges, of course. So if we take these particular challenges, how to improve those particular a priori algorithm. So the general idea is specified here. If these are the challenges, of course, to overcome these challenges, okay, we need to improve that a priori algorithm by reducing passes of transaction database scans, because as I already mentioned, multiple scans are required. So we have to reduce, we should reduce rather the passes of transaction database scans. Then shrink number of candidates, because number of candidates are more in case of huge data sets. Then the tedious job of what we can say, the counting support for those particular candidates is also there. So that should be what we can say facilitated inside certain what we can say the newer approach or improved a priori approach. And that's why these are considered as what the challenges and how those particular challenges are overcome, that is given here, so that there will be an improvement inside that particular a priori algorithm for the purpose of what we can say the candidate generation as well as calculating the frequent item sets. So this is what one of the technique for finding frequent item sets from those particular data sets in transaction data sets or whatever data sets are there. Another technique, that is what FP growth, that of course I am going to discuss in my next video. So hope you understood this particular concept properly. Thank you and keep watching my videos. Thank you friends.